Hello, teacher. Today I want to share a story about how molecules change their shapes. When we look at chemistry textbook, we often imagine molecules as hard, solid brain ball connected by stiff, rigid sticks. We think they are completely rigid. 这词不好念 rigid. But in reality, molecules are much more like water bomb. If you gently squeeze one side of water bomb, the water inside shifts and the whole bomb changes its shape. For nearly 100 years, scientists saw molecules behave like those rigid sticks as a groundbreaking paper published recently proposed that molecules are actually structural waterborne. They change their shape completely when interact with other. Okay, now you may wonder if molecules are like waterborne, why did scientists know this before? Well, it's all because of the camera they use for the casting. Scientists real right? Scientists relied on a tool called NMR to take a picture of molecule. You can think of NMR as an X-ray machine. It's great at looking straight so everything to see the bone, the very center of the atom, which we call the nucleus. However, when a molecule stretches is the other causing the aircon code that actually move and shift because the X-ray camera only studies at the bone is completely missing how the codes will change. This created a massive blind spot leading generation of chemists to believe a false stone. So, what happens when a molecule meeting an echo trench? Instead of staying still, sorry. So, what happens when a molecule meets an echo trench? Instead of staying still, the molecule orbital could react. They will move, change shape and structure. To understand this, let's compare two different atoms, fluorine and chlorine. think of Korean as teeny. Hard candy is cold, is tied, tied and doesn't dry easily. But think of Korean is big, soft marshmallow. Sorry. But think of Korean as a big, soft marshmallow. When Chenji push it, the Korean marshmallow easily starts its cool out share the butter. This show then softness, or what we call porability, matters a lot when molecules are all alone in a vacuum. However, However, everything changes when we drop this molecule into water. The difference, the difference between these molecules in water just like a basketball game. You can imagine a molecule called trifluoroacetic acid (TFA). It's like a regular basketball player walking into the sand because he is smell. The water fan can cool very close to him. Sorry, the water fan can cool very close to him, but but this cause contact make him feel very stable and supported by Kong. And on the other hand, the molecule called TCA trichloroacetic acid is like a gelatin mass in a big full fin shape, even though the muscle shape is soft and squashy, mean it stretches easily. Its hard size keep the water fan at a distance. They just can't get as close. This is why environments can completely fit how these molecules behave. So, thank you for listening. I hope you now see the molecular world is not reduced. Sorry. I hope you now see that the molecular world is not reduced, but beautiful, soft, and dynamic.